Hello, this is checkpoint 5.5 from section 5.1. They want us to find an upper sum for this function f of x is equal to 10 minus x squared on the interval from 1 to 2 and let n equal 4, and then sketch an approximation. So we have to, before we can find an upper or lower sum, we have to know whether the function is increasing or decreasing. And for this, I mean, we don't need to do calculus. You can if you want, but I see this as an x squared that's been turned upside down. So it's an upside down parabola. And the vertex is at 0, 10. So it's been shifted up 10 units. And then you're going to go from 1 to 2. So between 1 and 2, it looks like is going to be the part of the parabola that's going to be decreasing, going down. I think it hits the axis at square root of 5, positive and negative square root of 5, but that's farther out, so we don't need to worry about that. So we're really approximating the area under this curve from here to here. And from there, you can see that it's decreasing, and because it's decreasing, the rectangles that you want should have a left approximation. So the upper sum for this, so upper approximation sum is going to be the left-hand endpoints, and n is equal to 4 in this case, so we'll put 4 there. So we can plug it into the formula, or we can just remember what how to break up our axis, our partitions. 1 and 2, I think we did something similar to this. 1.25, 1.5, and 1.75 would be the values that we would be interested in. And if we're going to be using the left endpoint, we're going to be using the left endpoints. We'll be using these three values to get this upper approximation. So the left value, left value, left value, and left value. There. So it's all above the graph. So this is our sketch of our approximation. Let's actually do the computation now. One more thing that we need here is our delta x. Our delta x is going to be 0.25 or 1/4. And I think we're all set. So the sum is going to be approximation. It's going to be L4. And that is going to be putting this into the function. Our function is f of x is equal to 10 minus x squared. So we will put, well, let's do the summation notation first. I goes from 1 to 4, and we're going to use this function. And in this function, we will put x sub I. Let's start from 0 to 3, because I'm looking at x sub 0, x sub 1, x sub 2, and x sub 3. This is x sub 4, but we're not going to plug in that one because we're using the left endpoint. All right, so let's rewrite this going from 0 to 3 of x sub I. And then, don't forget, this is the height, and then the base is delta x. So it's 0.25. Okay. So let's just, let me just write this out. See how it'll look like. This is going to be 10 minus 1 squared plus 10 minus 1.75 or 1.25 squared plus 10 minus 1.5 squared plus 10 minus 1.75 squared. All this will get multiplied by delta x. And then this will be what you'll put in your calculator, computer, or whatever. And then I got the value to be approximately 8.03125. Okay, and that kind of makes sense. This whole thing is 10. And if I draw a rectangle from 1 to 2 with height 10, that's going to give me 10. So this value that we got is less than 10, a little bit less than 10. So it seems to make sense. All right, I hope that helps.